Okay, welcome back. What I want to do is to continue with the level 3 NVQ, Electrotechnical Systems and Equipment for Building Structures and the Environment. Okay, and again, this refers to the 2357 and the 5357. Now, although the 2357 has been replaced by the 5357, some of you will still have not completed this work, okay? But this knowledge is relevant to either side, okay? And we're doing session 8, types of cables, okay? We can get that into there. Okay. Types of cables. Now, state the features, applications, advantages, and limitations of various types of cables. Okay. Now, this session is an introduction to wiring systems. The term wiring system generally means cables such as PVC, SWA, MICC, and XLPE. Okay. Now, the term wiring enclosure refers to the conduit, trunking, tray, and baskets that hold the wiring in place. Okay. Now, each of these cables does a different job. It does a relevant job, okay? And the insulation also means something as well, applies to these cables for a reason. Now this here cable here, you will have as a grouping of cables within one given loom, okay? So here again, you have a set of cables that may be for different purposes. So you need to have the correct cable for the correct job. Yes, okay, we can select that before. Okay, good. But insulators. Now, to correctly choose the right cable for an electrical installation is very important. There are various factors to consider: the conductor material, the conductor size, the insulation, the wiring system it will be installed in, any environmental factors. Okay, all this matters. Now again, you will need to refer to the IEE regs in regards to your standards that you need to ensure that you are compliant with cable and the appropriate size and type and purpose of installation. And again, safety, safety, safety. You must comply with the IEE regs. At this moment in time, it is the 18th edition of the IEE regs. In the electrical industry, there are a wide variety of conductors and insulators that are commonly used. And there is a whole science linked to each area. Typical conductors include copper and aluminium, by far the most common. Others include brass, silver, steel, cast iron, mercury, tin, bronze. Now, conductors are either stranded or solid. Solid conductors are cheaper to manufacture but harder to install because they are not very pliable. Strand conductors are made up of individual strands that are brought together in set numbers 3, 7, 19 or 37. Now bear in mind of these numbers because these numbers may have changed since, and there may well be other cables that has number system that has been applied due to changing environmental conditions. Okay, so you need to check and look at your IE regs to ensure that you are compliant with these structures, or do some groundwork of your own. Excuse me. Okay. Now, properties of conductors. Different metals are used for a variety of reasons. These include how good they are at allowing current to flow, their strength, their malleability, density, their ability to withstand chemical attack. The main advantages and disadvantages of copper and aluminium. Now, here you have copper. Advantage: easier to joint and terminate. Disadvantage: more costly, heavier. Aluminium: cheaper, lighter, bulkier. It's bulkier. Not recommended in hazardous areas because there's a chance of chemical reaction in regards to aluminium. Okay. Okay. Cable insulation. Now again, BS7671 has changed the way it shows cable insulation types. Appendix 4 now lists cables under the generic properties of the insulating materials such as thermoplastic and thermosetting. This makes it easier for the designer to select the most appropriate cable type for its ability to handle specific conductor operating temperatures. Okay. Now, thermoplastic insulation. Thermoplastic insulation is also known as thermosoftening and is a polymer that becomes pliable or able to be molded above a specific temperature and return to a solid or hard state upon cooling. Now, a simple analogy to a thermoplastic is a chocolate bar. When a chocolate bar is melted, it has the ability to take on a new shape as it cools. This ability to be molded again and again is characteristic of thermoplastics. When very cold, thermoplastic insulation becomes very brittle, and it is for this reason that cable having this type of insulation should not be installed in cold conditions. Okay. Just make sure that we get it in frame, okay, and that it can be easily be read. Okay. Now, thermosetting insulation. A simple analogy to thermosetting insulation material can be described as being similar to a birthday cake. And I've given you a little birthday cake here, okay? Similar to birthday cake. Once a cake is baked, it takes its final shape. Baking it longer does not increase or decrease the size of the cake. Ultimately, if enough heat is applied, it will burn, but not melt like a chocolate bar. This particular characteristic is why thermosets are useful as durable materials and do not soften under high heat, such as car tires or flat roofing membranes. Okay? Therefore, thermosetting materials are created from the thermoplastic polymers by a process called curing. During curing, the polymer chains of the thermoplastic become cross-linked by some smaller molecules, and these are often referred to as cross-linked material. Such thermoset materials are called cross-linked polyethylene, or XLPE. Okay. Choosing a material for an application. Now, knowing that the key difference between a thermoplastic and thermoset is in the way they respond to high temperatures can be an important aspect of which material to choose. For example, thermoset materials are often chosen for circuits that may experience an overload. This is because thermoset materials have a reduced likelihood of failure if momentarily operated at the higher temperatures that often accompany an overload conductor. Comparatively, thermoplastics are often easier to strip, which makes them easier to process on automated equipment for large volume applications. Okay. Now, single general type is the 6491X, which has a thermoplastic insulation. It is commonly installed in surface-mounted or embedded conduits or similar closed systems, and for fixed protected installation in or on lighting fittings and inside appliances, switchgear and control gear. Use table 4D1A for current carrying capacities. Now, keep in mind that use table 4D1A. Now, this table may have changed in any up and coming IEE regs. At this moment in time, it is the 18th edition, and therefore this is still applicable at this stage in time. But allow for the factor that in due course and in due time, this may begin to be modified or changed to be something else in your 19th, 20th, 21st edition sometime in the future. Okay. And this is your conductor here showing solid but can be stranded. Okay. Now the biggest size that I've come across in regards to an earthing conductor is 2.5 mils solid. Okay. 2.5 mil solid, maybe up to 4 mil solid, but I think that's the maximum size. If you've got a 6 mil, then I believe it becomes stranded rather than solid. Okay. There is a firmer setting insulated cable coded 64B1 etc. This is LS low smoke zero halogen. Okay. The typical applications are for power and lighting circuits and building wiring. What it means is that in this case here, if there was a fire, it will give it, the smoke is going to be less. So it will allow you or the occupants of the building to escape without having to fight their way through a lot of smoke. Okay, that's the idea behind this. Okay, but again, look for any improvements to this system of cabling. Okay, it is not fixed. There's always ongoing developments. Now there's also TriWaste cable panel wiring. This is a high temperature and flame retardant cable designed for use in the switch control systems, relay and instrumentation panels of power switchgear, and for purposes such as internal connectors in rectifier equipment, motor starters and controllers. TriWaste cable is sometimes referred to as BS6231 cable or panel wiring cable. Okay. Okay, let's go. Okay. Now here is the cable that you would use on domestic installations or commercial premises. Okay. This not exclusively, okay, but you would normally use this exclusively for domestic installation. And again, be aware of the codings, because in due time codings may change or be upgraded as new systems come into play. Okay. And you have your multi-core cables. Okay. And again, just shows you here your twin and earth cabling, your 3-core and earth cabling. Okay. And there is a 4-core and earth with this as well. Okay, so keep that in mind as well, please. Thank you. And here you have your advantages and disadvantages, okay? Okay. Just pan back, make sure we can get it all in, okay? Okay. Mineral insulated copper cable. Now this kind of cable in here is used for fire installations. Now this is very good for fire installations, okay, and it's normally used for that purpose. Now it may be used in certain situations where you may have hazardous areas, so be aware of that. This is very good for utilization in the appropriate hazardous area, okay. But once you have installed this MICC cable will last for, it'll just stay there for 100 years or more. Excellent stuff, but very expensive. Now you can see here that can range from 1 millimeter square to 400 millimeters square. Now this is massive size. I mean, this is like you would find in a power station or something of the sort, basically. But 1 mil, 2.5 mil, 4 millimeter is normally what you would use on average in commercial and industrial environments mainly. Okay, but it's not set to that. Okay, it depends on what is required by the company at that point in time and what equipment is going to be used to control and supply. Okay, so you can see here that's magnesium oxide, okay, copper sheath is the outside, solid copper conductors. Now the problem here is that when you try to connect these up, right, because you have to strip the outer conductors, you have to strip the outer sheathing, right, which is copper. Sometimes little pieces of copper become wedges themselves between this gap here. So when you come to measure it out or you test it, you find that it goes down to ground. So you need to make sure that when you're connecting these up, that every last piece of fiber of copper has been removed, okay? Otherwise you'll get a defective reading. Now on here as well, you see that cable comes with appropriate sizes, okay? So here, nothing to concern about. Cable comes with 1, 2, etc. So many conductors. They are quite, it is quite a versatile cable type. Now here, and here's where we have, this is terminating MICC cables, okay? It is for terminating MICC cables. This is what we will need to do to this cable, okay? So this cable here is now this termination here. So we need to be sure that when we come to terminate, it's done correctly. and it is very important that it is done correctly, because if you get pieces of copper, as I said earlier, between these conductors here at all, it will short out. That's why you must test every time, safety, 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 before you connect to the final circuit and put supply on the line. Okay, very important. Check, check, check. Armored cables, okay, again here you look at your strand of conductors, okay, etc. That is your galvanized steel wired armoring. Now remember, the steel wired armoring, it can be used as an earth bonding, but always have an additional earth bonding within your system if need be, because what sometimes happens is that where this has been clamped to your, where you've made it off into a box, somebody comes along and tries to undo the clamp for whatever reason, and then you're then left with no earthing. So you need to make sure that when you're using steel wide armor cable, that the earthing is consistent. Okay. Okay, and here you are. Okay, so you can see your armored cables now. Okay, so okay, let's just see if I can get into it. Okay. Okay. Making sure it's in frame, okay. Okay. And usage. Now here is how you will connect your MICC cable, okay. It's secured now. So we're coming from, sorry, let me just go back. Sorry, my apologies. Here's how we secure our armored steel wiring cable, okay? Steel wired armored cable. Sorry about that. Okay, and here you'll see that your flange bonds your cable here. Now, for whatever reason, your outer strips, cable strips, let me just go back a little bit. These galvanized steel wiring outer armoring here, that will form your bonding, okay, that will form your earth bonding, okay, as well. But you'll see that it is always advisable to having an independent earthing as well, okay. Okay, just full in frame. Okay, good. And here you have PILC paper insulated lead covered. Now this is heavy cable used for supplying possibly to some distribution boards. Okay, this you can read for yourself. Okay, overall you don't need me to be reading this out to you, you know. So make sure we can get it all in. Okay, yes we can. Okay. Sorry about that. Okay. Okay, good, good. Okay, I think we're in frame. Okay, good. Okay. And the synthetic rubber. Okay. Again, that's normal use, practical use stuff. That will act as your pendant cable from your for your light in your bedroom or in your living room, etc. Okay. And with the cable here again, securing clamp shows you how it is. Again, your outer sheathing can be used as an earth, but you will find that there's an internal earthing as well. Okay. Always, because this flange can become loose. Okay, so bear that in mind. Okay. 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 Great. Data handling cables. Okay. Now, what here you have quite. There are 5 main types of cable available for data networking. Now, this is due to this can be updated because we're now going to 5G, and again that might require a different type of cable. So allow for the fact that could be for future development. Okay. So unshielded twisted pair, shielded twisted pair, screen twisted pair, coaxial fiber optics. Okay. Okay. And here you have categories. Now, twisted wiring is cheap to buy and install with the tools necessary, also being less costly than that used for fiber optic cables. The purpose of the twisting is to reduce noise. Okay. So let's get you into that. Make sure you understand what that concept is about. Okay. Right. And that is for you to read for yourself now. Okay. So let me just pan back. We can make sure we can get it in full. Okay. I'm going to go in closely. Okay. You can see category 1s. Okay. Tells you what they are and the frequency to which they can respond. Okay. Category 2, 3. Okay. Again, telling you what the response can be. Okay. And you can see it goes up to 100 megahertz, category 5. Okay. And here you have class F, supports frequencies to 1000 megahertz. That bring you into the gigahertz range. Okay. Okay, let's come back. And here we can get everything into frame. Okay, yes, we can. Go back a bit. Okay, thank you. Connections. Now connection matters, okay? A loose connection will generate heat and will break and deteriorate in a very short space of time, okay? So this is for you to read yourself. I don't need to be doing anything on that for you, okay? Right here, STP shield twisted pair cabling has some clear advantages over UTP, okay? And here you can see that we are showing you that now is the advantages in itself. And again here you can read this for yourselves. Don't need me to do anything further here for you, okay? And again here we're looking at this in more detail, okay? You can see that this here now shows you what it is. And again, let's make sure you get the information that goes with this. And again, you can use this for yourselves as you at your leisure, okay? Okay. And that's all coaxial cable, okay? You'll see that different type of conductor, the insulation, and your shaving with copper wire mesh or aluminium shaving, okay? And then your final insulation outside. This here limits and minimizes any interference. It's to shield this from interference. This shields this from interference. Let me get it right. Okay. Okay. Now here you have fiber optics, okay? And what I want to do is to make sure that we get the information how this is constructed, okay? You can see here your cladding, okay? Fiber optic fiber core itself, okay? Dielectric strengthening material, okay? Which could be plastic itself as well. Protective buffer or coating, outer jacket, and that formulates your conductor for your fiber optics. Now here we're looking at what? Coating so many microns, etc. Okay. Now with fiber optic cabling, not only the cable changes from being made of copper to being made of glass, but the means of transmitting the signal changes from electricity to light. In effect, a light source, usually a laser beam or LED, sends a signal down a very thin length of glass. The light source flashes on and off in the pattern of the electrical signal. Okay. Okay. Good, good, good. And here's your additional information, okay? Okay. Fire resistant cables, okay? FP100, FP200. Let's just make sure you can get this yourselves, okay, here, okay. Excuse me. Okay. And here you have FP400. It's a tough, armored, fire-resistant power cable for essential safety circuits associated with fire detection, fire alarm and emergency lighting, in particular for use in power supplies to safety systems. FP400 maintains circuit integrity during a fire, produces very low levels of smoke and virtually no acidic gases, less than 0.5%. This safeguards human life and protects equipment. Okay. And FP400. Now again, look this up for yourself. Make sure that now there's nothing to say that there isn't going to be additional new type of cables coming online. Okay, so again, be prepared to be updated and keep yourselves updated as well. Okay, multi-choice questions now. Thank you. Okay. All right, that's for you to do. That's for you to do. Okay. That's for you to do. Okay. And okay, thank you for your time. Have a good day. Bye bye for now.